Let's talk about the intermediate value theorem. Now, the intermediate value theorem has two conditions. The first condition is that we need f to be continuous on the closed interval AB. Closed meaning we want to include the endpoints. So if you look at this picture, we have A, we have B, this is our curve f over here. And we can see that between A and B, our function here is continuous. We can draw it without lifting our pen off the paper. Okay. The second condition that we have is n is a number between f of A and f of B. All right, so I need to adjust my drawing a little bit. Right now it says a Z. I'm going to change that to an N. Okay, so that's N. And what we can see is that this number N, according to my drawing, is in between f of A and f of B. Then what is the conclusion of the theorem? The conclusion is there exists a point C in our interval, and that interval is going to be an open interval from A to B, such that f of C is equal to n. Okay, now the first two parts, these guys are the conditions. So that's these first two pieces. And then this last part here is the conclusion. All right, so this is an if-then statement. So if the conditions are true, then the conclusion is going to be true. So when we look at our drawing on the right over here, we know that n is between f of A and f of B. That's the second condition. We know that f is continuous from A to B. That means there is some point inside the interval AB, so that we're going to call that point C, so that when I look at the y value of C, that y value of C will equal to n. That's what the intermediate value theorem tells us. So I think this would become a little bit clearer if we looked at an example. So let's take a look at example 11 together. All right. So we want to show that f of x equal to sine x has at least one zero. So what we're going to do is we're going to first argue the first condition. So the first condition is that f of x is equal to sine x. And we know that this is the function that we're going to worry about. I need to pick an A and I need to pick a B. And I happen to know what the graph of sine kind of looks like. So I know that if I let A equal to negative pi over 6, and if I have B equal to pi over 6, I think this is going to work out for us. Just because when you look at the graph of sine kind of looks like this. I'm having my A to be to the left of 0, and my B is to the right of 0. And in this case, I'm taking A to be negative pi over 6 and B to be pi over 6. So from this graph, you can see, oh, it's going to cross the axis. This is just an example to show you how the theorem works. And what the first condition says, just as a quick reminder, the first condition says f is continuous. So what we're really doing is we're really running a proof, right? We're showing that f of x equal to sine x has at least one zero. So for the first part of my proof, I'm going to need to state that f of x is continuous. We know that f of x is continuous on its domain since it's a trig function. And we know that all trig functions are continuous on their domain. What's the second condition? The second condition is we need to pick an n. So our n is going to be equal to 0. Why did I choose n to be equal to 0? Because I want to show that f of x has at least one 0. So that means my n is going to be 0, right? And then the second thing that I need to verify is when I take f of negative pi over 6, f of negative pi over 6, that's the same thing as saying sine of negative pi over 6. And sine of negative pi over 6 is equal to negative 1/2. I'm going to evaluate my f of b now. So my f of b is going to be f of pi over 6. That's equal to sine of pi over 6, which we know is 1/2. So just to make it perfectly clear, this is my f of a in the theorem, and this is my f of b in the theorem. And in case it's not totally obvious, n equal to 0 is between negative 1/2 and 1/2. So what have I just done? I've just shown that my function satisfies the two requirements of the intermediate value theorem. Namely, it's continuous on the closed interval from negative pi over 6 to positive pi over 6. And this number n is between the f of a and the f of b. So the conclusion I could draw, we're going to put 3 circles. This means therefore, by the intermediate value theorem, which I abbreviate IVT, there is a point C in the interval from negative pi over 6 to pi over 6 such that f of c is equal to n, which is equal to 0. So to conclude, this means f has a 0 at this value c. Okay, so the intermediate value theorem is mainly a proof that shows us a function attains a particular value, and we've just proven that this particular function sine x attains the value 0 at some point in between negative pi over 6 and pi over 6. All right, everyone. I'll see you in class. Take care.